we need to make matches logically work and then have a visual reflection of that by having the blocks like perhaps light up and emit more light or turn shiny, more specular. And then there's a timer bar in Lumines, which we haven't mentioned yet, which comes across the screen as you play the game just in real time. The timer bar starts at the left and moves across to the right, and then starts again on the right, on the left hand side to the right, and just keeps sweeping from left to right. And that bar is what turns the matched blocks into cleared blocks. So there's a block can exist in an unmatched state, a matched state, a cleared but not yet destroyed state, and then once the timer bar reaches the end after sweeping past a matched block and turning it into a cleared block, once the timer bar hits the right hand side of the grid, that's when the cleared blocks actually get cleared. So there's a better name for it than cleared blocks, but it's highlighted, I guess, is what I would call them. Unmatched, matched, and highlighted, which is perhaps misleading because we want to actually visually highlight the matched blocks, but then we want yet a third visual state for the highlighted blocks, which means they're about to be destroyed as soon as the timer bar finishes that sweep. So if that didn't make any sense, then at this point, by now you hopefully have watched some YouTube videos of the real game Lumines, or you've watched the intro video that I made for this series, which shows the finished version of this project. Will be, the game that's you're seeing at the start, so that has the timer bar in place already. So that's what I mean by unmatched, matched, and highlighted blocks. So let's go ahead and get into it. Enough staring at the empty grid. We need to have states for the blocks themselves, so we need to add that to the block actors. The color is separate from that, but that does play a role in each state's actual visual color. So we'll have this is where we'll probably need an enum. So we'll go ahead and make an enum called block state. E_block state. Again, not the perfect name for it, but whether the block is unmatched, matched, or highlighted, aka about to be cleared from the board. So the 0th element of this enum will be unmatched. Then we'll have matched. If you've never heard of an enum before, it's just a way of basically having more than one Boolean value, like true, false, and extra false or something like that. It's just like 0, 1, 2, 3, 4. Just they're basically integers under the hood that just you can use names to give each integer value some meaning for whatever purpose you're using the enum for. So again, they have descriptions for each state, but I think it basically speaks for itself for now. If there are any specific considerations to make at each state, we would add those here later. But for now, it's still overall pretty simple, so I think just the names are descriptive enough. Now, I'm just going to say my state for the blocks. Now that's not all-encompassing, because another implementation of this game might have a falling state, or a spawned state, or a idle state or something like that. So the term state is so vague that I'm probably not doing myself any favors by calling this my state, but I'm just going to call it my state. So the default value of this will of course be unmatched, because when a block spawns in, it is not matched, and it is not highlighted either. So what's going to cause them to become matched? That's going to involve some more ray traces, because we're going to need to, once a block has reached its resting place, then we run a check on all adjacent blocks to determine whether there's been a match. But we do need to be careful. We need to be explicit when we define what a match actually means and what constitutes a match. So in Lumines, a match, blocks are only matched when they form a square of at least 2 by 2, or any sort of rectangle that's at least 2 by 2 of that solid color. So if we were to pause the game right here, these 4, if you imagine this, there's 7 orange blocks here, right? But if you imagine a group of 4 blocks here, if I eject, these 4 blocks form a rectangle that is going to be matched, and also these 4 blocks represent a matched rectangle, and they will, in fact, this will in fact give you the points for 2 matched rectangles, even though there's only 7. So that's one of the edge cases. Like, there's many different configurations that result in different types of matches. And one other thing I should mention here is if we do this and then pause again and look at the shape here, this is actually like a 3 by 2 rectangle. But I think the way Lumines, the real games, work, at least the first one, is this will count as 2 by 2 squares. So this actually is 3, this whole orange shape, all 8 of these blocks, is 3 2 by 2 squares. So even though it's only 8 blocks, you're getting points as if it was 12 matched blocks. And hopefully that makes sense, because you have 1 2 by 2 square here, which is, you know, these 4 blocks that I've highlighted, and then 1 2 by 2 square here, and then a third 2 by 2 square here. So if we want to get scoring true to the real game, we need to be careful of how we determine matches and what determines like a 2 by 2 square. This particular square is part of 3 matches, and this square is part of 2 matches. So let's talk about how we're going to get matches working with ray traces and stuff. The only way this one is matched is if all 3 of these ones, including this diagonal one, are the same color as it. So what it does is, like, you know, checks the top 3. No, it needs to check to its top right, to its bottom right, to its bottom left, and to its top left, and the, you know, adjacent ones that include that one. So, like, you know, checks its diagonal top right, and also the 2 adjacent ones that are part of that potential square. And it needs to do the same thing for the bottom right and the one below it and the one to the right of it. So, you know, when you say top right, you're also including the top and the right. And when you're saying bottom right, you're also including the bottom and the right, and so on for the other 2. So if the 3 of any one of those checks are all a match, then that particular block is matched, right? So that may even solve the issue right away of, like, multi-counting a block. So like this block, you know, is part of 3 squares, as we discussed before. So if you run the, you know, check above and to the left of me, it'll check these 3 and they're all a match. So that's one match. And then you check to the top right and say, okay, these 3 are also matched, so that's a second match. And then it checks these 3 and says, okay, those are all the same, so that's a third match. And then it checks these 3 and says, oh, they weren't all the same, so that's not a 4th match. So hopefully that makes sense what I just said, because I think that that's a decent solution. There may be something I'm not considering that will cause false positives or false negatives. It should work properly, and I think that would work in any situation here. So, like, you know, this tile will be part of one match as it looks to its bottom left and sees these 3 are all matches. That'll count as one match, and then it'll check these ones and they're empty or they're non-matches, so then it will, you know, say in total I'm a part of one square right now, one matched square. And so I think that that will work. So let's go ahead and try implementing that. And right away we need to make a pretty big design decision, or a project-wide structural decision. But for when a block is set to determine its matches by looking at all 8 sides of it, look at these 3, look at these 3, look at these 3, look at these 3. Should that algorithm be performed by the block itself within like a function on each block, or should the game mode have its own function that takes in a block reference and looks at the adjacent spaces for that input block reference? So basically what I'm asking is, do we want all of the like heavy gameplay computation logic to be contained in the game mode, or do we want to spread that out to the actors who are involved primarily with that action? So like the blocks could decide for themselves whether they're going to change color or change state, and so the game mode or the player controller could issue the command to the block saying, okay, run your function to decide if you're a match now. Or we could have that run in the game mode itself, taking in a parameter saying this is the block that we're currently comparing. So I feel like either one works, and it just depends on what you think makes more sense, or maybe one is more performant than the other, or maybe one is more logical to someone than another way, and maybe that's subjective, or maybe there really is an objective best way to do that kind of thing, or a best practices. But I'm gonna go ahead and probably do it on the block, I think, because it's something that really only affects the block individually, so it might as well be the block's decision to do it. And it probably won't be too difficult to even move this from one blueprint to another blueprint, like from the block to the game mode, if we decide that's better later on. We just have to change a few variables around and copy and paste the function in. But I think I'm just going to go with it in the block for now, because it seems right to me to kind of distribute the load that way. But that could also be a mistake, so I'm just going to do it for now, and I think it's fine, but we'll see. So let's make a function called determine matches. So determine how many matches this block is a part of, if any. So that means there'll be either 0, 1, 2, or 3 matches that this block is a part of, and a match is just a 2x2 square of all the same color. So even if there's a 3x2 square of all the same color in the game, that would be 2 matches. Like the 2 blocks in the middle row of this 3x2 group would be part of 2 matches each, and the bottom 2 are part of 1 match each, and the top 2 are part of 1 match each. Hopefully that makes any sense. But that's just how we're going to define the word match. It means I am a block that is a part of a 2x2 square of adjacent same colored blocks. So to determine this, we're going to have to do a ray trace for each block that we want to compare against. So let's get actor location, which is our own location as a block, and then we will perform a line trace for objects. The only other objects we'll collide with are the collision boxes on the corners of the map, of the grid, and the other blocks adjacent to us. So we might run into issues with matches on the corners if we don't account for those, but for now we're just going to focus on matches in the middle, and we'll add the special case for dealing with the collision boxes. There may not be a special case, because if you're a block situated along the edge, like you're a block here and you're going to check your corners for matches, you could check here and it's not a block, or you'll hit something but it's not a block, so it just doesn't matter. You will fail your top right check because there won't be 3 blocks to match. So whether it's a different colored block or not even a block at all, it's just going to make you fail that particular test. So that should be fine. But we'll see. So now we're going to have a lot of line traces, like probably, 12 total for each block every time it runs this function, because we have to do 4 times. We have to do 3 checks, and we're doing 4 sets of 3. So we'll start, again, an arbitrary choice, but I'm going to check to my top right. So if I was, this block, if I was this center block, and then I had to check the top right to look at these 3 tiles, and then check my bottom right, look at these 3 tiles, and then check these 3, and then check these 3. There could be a way to optimize this. You could just do 8 checks and then compare the results of, get the 8. Maybe I'll do this as I'm talking it out. It sounds reasonable, but you can, just do your 8 checks and then put them all into an array, like all the results, and then say, like, is index 0, 1, and 2 all the same? If so, and they're all the same as me. If so, increment my, num matches value, and then do index 2, 3, 4, index 4, 5, 6, and index 6, 7, 8, right? Like that seems reasonable. So maybe I'll do that. Hopefully that made sense, my discussion just now, because it's not really any more difficult to implement. It's like one extra step of saving things to an array, but then you don't have to do like 4 extra like sub functions that are like check my top right, check my top left, check my bottom left, check my bottom right. Instead, you just check all 8 adjacent spots, and then compare your results to, the certain indices that relate to the matches you could be part of. So I think either way, it's about the same amount of work, and doing it this way saves us, from doing 50% more ray traces every time we're doing a block check. And we are probably not that worried about performance, but if we end up having to call this function really frequently, which we may, because you have to call it again every time, you might have to call it on every single block, every single time the player, drops something, and every time the timer bar reaches the end, because all the blocks are going to have to fall down to fill the gaps that were just created, and then every block's going to have to rerun the check, and we might as well just make it as performant as possible, because it could be a high traffic area of our code, which is frequently used, so we might as well try to optimize it. And I'm working under the assumption that a ray trace is relatively expensive in terms of performance, so if it's not, then I could actually make this could actually end up being less performant, because I'm making extra arrays and then filling them and then reading from them. That could be worse performance than doing a few extra line traces, but for now I'm just going to do it like this with the array of 8 results, and we will see how that ends up being. Let's go ahead and start doing some line traces and see how we want to structure this in the long run. So it's time to make yet another arbitrary choice about why I'm doing things the way I'm doing them. But I was tempted to maybe start my ray traces here. If you've ever had a math class where you talk about the unit circle, you tend to like start here, and then you go counterclockwise 2 pi for one rotation around the circle. So you could start here and then check in this order, but I think what feels more right to me is to just start here and make this be like index 0 of the results array, and 0, 1, 2, 3, 4, 5, 6, 7. If I had to describe why I think that's right, I'm not really sure, but maybe it's because it's like a clock. It starts at the straight up position at midnight or 12 o'clock, and then you just go around the clock and back where you started. So I don't know, I'm just going to start here, and you got to pick something, so that's what I'm picking. So we're going to start straight above us, so we're going to just do one offset. So we start on us. So every single one of these is going to start, on us and then move up or diagonally up to the right, and or so on and so forth in all 8 directions. So there's going to be 8 of these. Maybe there's a better way to do this than just copy this 8 times, but for now I'll copy this 4 times, and if nothing better springs to mind, I'll just copy it again. So we're going to have straight up, which means we need to offset. We're going to have to, oh, well, here right away we've run into a reason why it might be better to do all this in the game mode, is because we're going to have to, every block is now going to need a reference to the game mode, which means we're going to need to, on construction, get the game mode. So get game mode and get a reference to that, so we don't have to call this function every time and cast it every time. So here's yet another variable, LPP game mode blueprint reference. Set that, cast to that type. Now again, this should never fail because there's only ever going to be the one game mode active, and when these blocks spawn into the game, it's going to be the game mode itself spawning them. So obviously, or it's going to be something spawning them, but in this case it is the game mode. So the game mode will be active at that time, so this will be valid. And now when we want to use, the reason why we need the game mode reference is so that we can get the vertical offset value. So this almost maybe equates to like a, pound include for in C++ or something. So that you need to include the object that holds all of the global variables. But I don't know if that's the best way to do it, but for now that's what I'm doing. So now we're going to just add vector to vector, split this, add this vertical offset, and that's the endpoint for this check. And we need a local variable called object types, eObject type query. So I can remove this, delete this. We don't want a variable with the scope of the entire object when we only need it for this one function. Change this to an array, set the default value to a 1-element array of type world dynamic on that 0th element, and just plug that in here. Now, I said earlier that I like to minimize the number of references, so it's not like, game mode, game mode, game mode, game mode, game mode, but I'm going to actually do that here because it's just going to look neater, I think, without all those wires coming out of one node over here. And it's also easier to duplicate it. When you already have the reference there, you can just copy and paste the whole thing and not have to wire everything up every time. We'll do a sequence, I suppose. When I first started using Blueprint, I didn't really use the sequence nodes very often. I just kind of went straight to the right, or I strung them together like this, which is fine, but I feel like the sequence node helps you keep track of the order in which things are going. With at a glance, it's easier to see what's happening, but that could just be my opinion. Maybe they're a huge overhead and they suck, but I think that they are okay so far. So we're going to assume the only things we can collide with are other blocks, and we're ignoring self, and in this case self is the block. Unlike last time where I made the mistake of thinking self would be the block, In this case it is, because this blueprint is located in the scope of the block itself. We're going to assume that the only things are other blocks or the collision boxes for the grid. The result of this line trace, when we perform it, is going to be an actor that was hit. And if this is valid, which it should always be, but I'm going to go ahead and call that anyway, and go ahead and cast it, because I'm going to need to cast it anyway. Cast to block BP. I need to cast it so I can get the Boolean value that I care about. So if it is valid and can be cast to the block BP class, then as the block BP, let's get its B is color 1 value. And if this is equal to our own is color 1 value, then we can, so this resulting Boolean value is what we're going to store at index 0 of the array. So let's make that array. Array of comparison results. A nice dry term. It's only ever going to be 8 elements long, so we can just go ahead and set element by index. We could, I mean, it would be good to do some sort of loop to prevent, duplication of this logic, but I can't think of a way we're going to convert, degrees of around this circle into indexes for an array. I can close this. It's been open for a really long time. So I'm just going to hard code these index values in here. It's, corresponds with the sequence values if that helps, but that's what I'll be doing. So we'll set the array element of this target array to this item. We don't need a size to fit because we've predetermined the array is going to be 8 values long. If we resize it every single time on these 8 times, that's just going to probably be more performance heavy than initializing it to size 8. So we'll do that. So our color, compare it to the object we hit's color. And if it's true, it'll be true at index 0. And if it's false, or if this whole thing failed to begin with, if the cast failed, which means it was a collision block, that array element is going to default to false, which is true to what we want. It's accurate to how we want to, of what we want this array to represent, where if it's true, that means it was a match. So if it's false, it was either not a match or not even a cube to begin with. So this should be the logic we need. We just have to duplicate this whole thing 8 times, which that'll be really quick, but really, inelegant. Hello, this is me coming from a few days in the future. I realized when I wrote this function, I was saying that I couldn't come up with a better way to perhaps create an array to iterate through. Instead, I decided to just do the same action 8 times in a row. So I have all 8 of the directions around the current block when you're checking for matches. And upon looking back at the video, I realized it's actually probably pretty simple to make an array and parameterize it and then loop through this function 8 times instead of doing literally the same logic 8 times like manually like this, hard-coded. So I'm going to quickly make an array of offsets and then iterate through that array of offsets and then just plug the index into this set array element node. That way we can condense this, just try to ignore everything here that we haven't covered yet and everything down here. For now, we're just going to focus on these eight things that I was just talking about, and find a way to make this a little bit more condensed, because if we need to change something here in the future, instead of having to do it 8 times every time we need to make a change, we can just, make this into a loop, and that way we only need to change it once. Because this is just a bad habit to get into, doing the same thing 8 times if you really don't need to. In this case, we really don't need to. So let's go over an alternate way so you don't have to put up with this suboptimal layout here. So I'm going to do the make array node. And this is just going to be an array of 8 elements, and each one's going to be the offset for that specific direction. We're going to start at the top again, at the 12 o'clock position, and go clockwise around the circle. So the reason I'm doing a make array node is because I can't hard code it here. What I need to do is make a local variable and call it offsets array, but I can't plug in the default values here because it's going to reference the game mode variable. So I'm going to need to make this an array of vectors, but just set it to the value of make array. This way I can make an array using another variable like this. So get vertical offset and get horizontal offset, and we're going to use these to form our vectors that we're going to plug into this array. So if I just hook this up to here, this will become vectors, and then we'll have to make vector. So it's a bit of a big ugly mess right here, but it'll be better than this big ugly mess, I'm pretty sure. So I'm going to just look here. What we're going to do is for each index in this, I'm just going to take this exact value here, like this vector that we're adding to our location is the vector that I'm going to put into this. So it should be pretty easy to just kind of think it through step by step. So 0 is just going to be straight up, so it's just the vertical offset. So if I make vector here, now maybe it would be better to not make vector and instead just expand all of these. But I think that might end up looking even more confusing with 24 green pins in one node. It would say we have 3 pins per node and have 8 of these nodes. Like, it's just it would get really, really long if it was 24 green pins in one make array node. So I'm going to do it like this instead. So that's the index 0, and then index 1 is going to be, oh, I just realized I have 2 vertical offsets here. How silly of me. This should be horizontal offset, of course. Make vector 8 times. So yeah, that is, not optimal, of course, but it's probably better than having 24 pins in one node, hopefully. So that's 8 total for the 8 indices. And this is going to be up and to the right, so we need both of these. Horizontal should go in the X, vertical should go in the Z. I'll get there eventually, I'll figure it out. And I'm going to move these to like here. Again, even if this looks ugly, like this won't change very much, and if it does, it'll change due to these values, which will be changed elsewhere. So because it's always going to be one offset with the whole setup we have going, like this logic can be tucked away and collapsed even. This won't change much, if at all, but it'll make making the loop better. So we'll have 2 big chunks of logic instead of 8 big chunks of logic. I think that's better. So this is going to be directly right, so it's just the horizontal offset along the X. And this is going to be down and to the right, so it's going to be horizontal along the X. And then this times -1, so times integer and -1. So that's down and to the right. And now we want just straight down, so just this value again. And then we want down and to the left, so this value for the Z component, and then this value for the X component. And then we're going to have directly left, so just this value. And then we're going to have up and to the left, so this value for left, and then up is just going to be the vertical offset again. And now we just plug all these into our make array node. That'll shrink it down a little bit, thankfully. And now, this is a bit messy. I could make this say down and have this say left. And maybe make this say up just for consistency. Right. And if I spread these out a little bit, that might make it slightly less gross. And I can use a couple reroute nodes, but again, this logic is going to probably remain largely unchanged even if there's some refactoring going on elsewhere in the code. It's a bit modular because it just inherits from these values, and it's just the way the whole system is designed. One offset is probably going to be one offset no matter what we do elsewhere in the project, so it should remain the same. But this at least cleans it up a tiny bit. And I can even collapse this whole thing. Well, first I'll do it like this. And I can collapse this logic to a collapsed graph and call it make offsets array. Now I'll just give it that description, say populate the offsets array with 8 vectors representing the location offset from this block to its 8 neighbors, starting at the top and going in clockwise order. So now we got a handy little screenshot that we can look at a glance when we hover over this. And we'll move this around a little bit so it's not quite so weird looking. And now we have the offsets array. All we need to do is put this logic into a loop. So we'll get offsets array and do a for each loop on it. And instead of having this, we'll recombine these pins. Take this element and plug it in here, so that's the offset on this iteration, the offset we're going to use from our location. And the index needs to plug into this set array element node so that we set the element of the results array correctly so they correspond with the right one. So make sure that this plugs into the index node here, or pin here, and that should be all the changes we need to make for this logic to work. So now I should be able to just disconnect these 8 sequence pins and replace this whole thing with just this thing here. So that should be a lot cleaner. So I'm going to pause the video here and test it out myself, and then I'll let you know if it works. Okay, so I just tested out this new logic here, and it, as expected, it does work exactly the same. So it's literally doing the same thing as this. It's just a lot more compact visually, and it's I think this is more elegant and more easy to change in the future. So I'm going to go ahead and just delete all this. And in the videos that I recorded previously, I like to keep some of the stuff in there that I iterate through over the course of the videos because it helps to show what the actual process of designing a game in Unreal is like. But this one I didn't want to just leave hanging because it's not a good way to do it like this. Like, it should probably raise a red flag to you whenever you see this much duplication of code. If there's not a really compelling reason to do that, then when it looks so similar, you should probably wonder, oh, is there a way to put this in a loop? Because this looks pretty loop worthy. And in this case, it turns out, yes, there is a pretty easy way to put it in a loop. It's not ideal because you have to like make that array first and then iterate through it. So you're still doing the hard coding each position, but at least you're not then hard coding what you're doing with that over and over again every time. So I think this is better. And I will now return you to where we previously were in the video. It will include making that, but I won't show every detail of that because it's the same thing over and over again literally, so I'll just skip through that. But now you know a better way to do it, and you've probably already found other better ways to do things that I've demonstrated in this series so far, but here's another idea for ways to improve things. We'll go back to that now. So that is up and to the left, and that is the last one. So now we should be doing 8 ray traces out in all directions. I do want to check to make sure that's actually working, so I'm going to go ahead and draw these for a duration. I think that's 5 seconds. Now I have to duplicate this drop-down option. And now we need to actually run this function at some point, right? So this is where it gets a little murky, where should the player controller be issuing these like gameplay functions, or should the game mode be doing that? But anyway, we need to add the call to this function at some point. So I guess in finish falling we could do this. So in finish falling, before we spawn in a new quad, we can tell each member of the current quad to check its neighbors. But you know what? That's actually not how we want to do this, because, for instance, old blocks that are previously dropped and are no longer part of the quad, they also need to run this update function, this determine matches function, because they ran it when they were first the quad, and they're no longer the quad, but now they may be a part of a match. So this actually needs to run on every single block in play. So I think when finish falling happens, we can just tell the game mode to run determine matches on every single block that's currently in play. That's something that we may want to add an array in the game mode that keeps track of every single block that's in play as they are added to the game. That would be a more efficient thing to do, and it's almost like approaching object pooling, where we could maybe reuse blocks so you don't have to spawn in blocks in perpetuity, and that has some overhead associated with it. But I think we're just gonna, for now, if this leads to hitching, we'll obviously change this, but for now I think we can go to the game mode and we'll make a function in the game mode that says check for matches on all blocks. And so this is going to do just what it says in its name. It's going to get all actors of class. This is a fairly heavy utility function, which I think the tooltip even makes a note of that. It says, this is a slow operation used with caution. Certainly not every frame, but hopefully we're not using it so often that it's going to lead to slowdown or bad performance in general. So if we call this only when we call this function, and we make sure to not call this function super often, but we will have to call it fairly regularly, just not multiple times a second, but every couple of seconds, or even maybe every second, depending on how fast the player drops blocks into the game zone. But anyway, we need to get all actors of the block blueprint class, which will be all, actors that are currently in play. And we want to specifically get the ones that are not valid, as if they are about to be destroyed by the game. They've been matched and they're about to be destroyed, but we need to call this function again. We don't want to get all the ones that are about to be destroyed. We'll get some warnings and errors if we do that. So I do a for each loop here, and these are all the blocks that are in the game. We want to make sure they're valid, so we can is valid. Assuming this function works, I think this is literally equivalent to doing this. May be literally the equivalent of this, like this may be the exact same thing. But just in case it's not, I'm going to use this one because it says literally here, makes sure that the thing is not pending kill. So it's not this that's not null, but it's also not about to be destroyed. When an object is marked for destruction, it's pending kill, but it might still show up in this list. So we want to make sure we're just getting the ones that are still valid. So if we don't want to make this temporary array variable that just stores the result of this function, we can just use this where it is, and if it is valid, we run our determine matches function. And if it's not valid, we just simply do nothing. So we come into this function. We get every single block BP in the scene. We make sure that the ones that we want to work on are valid and not pending kill. And if they are valid, we run determine matches on them. So this will actually run determine matches, which isn't doing much right now. All it is doing the ray traces. So what we're going to see is like a porcupine, if this works as I hope it does, which right now it's not going to do anything because I'm not calling it. So let's go ahead and make the player controller check for matches on all blocks when the finish falling takes place. So a new quad has fallen into place, and now we're going to run determine matches on all blocks. Check for matches on all blocks. Now this, in general, I've been doing things like this in Blueprint where I, call a function from another object. That's probably not very good for like encapsulation purposes. In C++ you probably wouldn't do something like this unless you had a really good reason. So maybe I should be doing something different with like event dispatchers. I've never really gotten into this aspect of Blueprint, but I think you could do this to, basically do like the observer pattern, right? Where you say, okay, I'm just letting everyone know, if anyone's listening, a new block just fell into place and we're about to spawn a new quad. So then the game mode could listen to that and say, okay, I just heard that they're about to spawn a new quad, or they're about to ask me to spawn a new quad, because here again I'm telling the game mode to spawn a new quad. So perhaps I should refactor a lot of my blueprints that I've ever made and change this to do like, an observer pattern with listeners and like messaging or observer pattern. I think these are very similar concepts. That way we don't have to specifically have the reference to game mode and tell it to do something. We can instead let the game mode listen for a message or something that says, oh, I'm about to do something, or something important just happened. Then you don't have to refactor things when you change stuff around. But for a project of this scope, perhaps this is okay, but it's probably a bad habit to do something like this when there are more elegant solutions available. This works, so I'll just do it like this, but plenty of things work in C++. but it's not the thing you want to do most of the time. That actually was one of the reasons why I thought Blueprint was an easier way to get into programming with Unreal, because with C++, it's harder to do things correctly. It's harder to even know what you're doing right or what you're doing wrong in C++ because it's a bit more abstract, and you have to know what you're doing to know whether you're doing it right. Whereas here, I was like, oh, you just kind of drag the nodes until it works. But this could be a really poor way of organizing things. I mean, it's easy to find all references to, check for matches on all blocks. You can check all blueprints for it. So it really, doesn't discourage poor form. The whole blueprint system allows you to do this really easily. So maybe it's fine at the end of the day if it's easy to correct. If it ends up being an issue, you can just search for everyone who calls this function and find where it was called. That makes debugging really easy, and so maybe at the end of the day it's not that big a deal. So for now I'm just going to do it like this, but I do think there's probably a more elegant solution. Because imagine I extended this to, I ended up calling 10 different functions on 5 different actors. And I had references to all those actors, and I specifically called them all in a row like this. Instead, I could just have a messaging system or, a dispatcher that says, anyone who cares, I just did this thing. And then they'll say, when anyone tells me I did this thing, call this function. But that's splitting hairs at this point for a project of this scope. I think this is fine. So now that we're actually calling check for matches on all blocks, we can see if this is working as it currently should be working, which means all 4 of these blocks are going to sort of shoot out like a porcupine or a, what are those fishes that have quills on them? I don't know, but anyway, yeah, there we go. We have this star-like shape of all the quills coming out, checking for matches or overlaps. Let's investigate here real quick. Is this what we expect? I see some green ones here, which are perhaps a problem. Trying to go diagonally, but we're touching this block instead. So if we look in here, all these should be blue. All these, green rather. So the ones that are shooting straight up and down are green because they're touching the ones above them, which is what we want. But these diagonal ones are green, which is probably not what we want, because they should be red because they should be checking this tile here and not finding any block. But it's green, which means they're touching their neighbor, their top and bottom neighbors. So I think the reason for that is probably the block mesh itself has overlaps on it. So it's actually colliding with that, which we don't want. So let's change that. If we go to the block and go to the block mesh and just turn off collision and overlap events, because the block collision is what's going to handle that. Now if I drop this down, all of the visible trace debug lines should be red, except for the ones at the bottom, which are touching the grid collision boxes as expected. So that's good. That's better, I think. That is the desired behavior.